Hi guys, a request was made for me to make a few videos, so I'll be looking online for these. Number 72 from 9.3a. Heat through the glass. How well materials conduct heat matters when designing houses, for example. Conductivity is measured in terms of watts of heat power transmitted per square meter of surface per degree Celsius of temperature difference on the two sides of the material. In these units, glass has conductivity of about 1. The National Institute of Standards and Technology provides exact data on properties of materials. Here are the measurements of the heat conductivity of 11 randomly selected pieces of a particular type of glass. Forgive me, I'm losing my voice. I sound a little croaky. Is there convincing evidence that the conductivity of this type of glass is greater than 1? Carry out a test to help you answer this question. So we want to state what the true mean is. The true mean conductivity of this glass, is just the state, okay? That's what we're looking at. We're testing to see if it's greater than 1. Our HO, then we would assume that it is 1, okay? And then we want to prove, like it says right here, that it's greater than 1. So here's our state. 1 point, 2 points, 3 points on a test. The plan, we need our conditions and our method. First one, random. They do state that it's a random selection of 11 pieces of particular type of glass. Independence. We want to take 10 times the sample size. Has to be less than all types of glass. Normal. 11 isn't greater than or equal to 30 by the CLT, so we need to graph in our calculator. We sketch the graph. If we fold it in half right here, it's symmetric enough. With no outliers, and I should have typed that. Our method then is a 1 sample t-test for mu. So we have our plan done now. The plan is worth 1, 2, 3, and 4 points. 5 if you have to graph and say that's symmetric enough with no outliers. The do part, okay, so this is where I'm going to go to the calculator. And I already have my data in L1. Okay, let me move this up a little bit. You can see that there. So now I'm going to go over to stat, I'm going to go over to tests, and I'm going to do a t-test. I have data. My mu right now is 1. My data is in L1, and I'm doing a test that is greater than for my alternative hypothesis. I'm going to calculate. I'm now going to take a screenshot of this. Okay, so here's everything we need. What am I going to be looking for on the test? We can draw the curve, but right now I'm just at home, so it's hard for me to do a lot of drawing. So what I'm going to show you is really the bare minimum that you need is you need the t-score. So t is equal to, okay, and I'm going to put parentheses there. My x bar is 1.118 minus my mu, which is 1, okay? Where did I get that? That's from the null hypothesis. So my observation minus my mean, that always comes from the null hypothesis, divided by my sigma. And my sigma is equal to 0.04, 377, divided by the square root of 11. Okay, and that whole t-score then is equal to 8.9538. That's going to be on the test, 1.2 points, 3 points, 4 points. Next, we have our degrees of freedom, which is not on our calculator. That's worth 1 point, so 5 points now total. 11 minus 1, which is equal to 10. And then finally our p-value. And our p-value is equal to, now be careful, 2.1669 is not your p-value. You have that e to the negative 6. That means you need to move the decimal back 6 places to the left. So that's 0.00002, I believe. Now, I said anytime e is greater than -4 here, or it should be less than -4 technically. So if you have a -5, -6, -7, you can say approximately 0. And now we need to conclude. Because our p-value is less than 0.05, our p-value, back up. Because our p-value is approximately 0, which is less than our alpha, equal to 0.05. We reject the null hypothesis. We have evidence, right, that the mean conductivity is greater than 1. Hopefully this helped. You guys have a great cold day.